everyone. Myself Nisak Bhatti, student ID 10 14 10 311, and today I'm making this video to demonstrate the Python assignment 4. Now we'll walk through the Python assignment focused on a building and comparing a baseline convolutional neural network model with a regularized version using dropout L2 regularization and data arguments. By the end of this video, we'll understand how each step contributes to reducing overfitting and improving the model generalization. Now, step 1, of course, we are going to import the necessary library. NumPy for numerical operation, Metabolic for plots, TensorFlow, which is our primary library for neural networks. And to split the data sets, we are going to do the Scikit-learn train and test split. Now let's load the Cipher 10 dataset using this. It has a 60,000 color images 32 by 32. After loading, we need to normalize the pixel value to range between 0 to 1 to speed up the work conversion during the training. Now, the normalizing the images is a crucial and stable stable step for our fast training process. While the dataset already provides a test set, we further split the training set into the new training set and a validation set. So here it is. Now we have the random state at 42 to ensure our reproducibility. And now we are gonna construct our baseline model. This is a sequential CNN model with 3 conventional layers followed by a fully connected dense layer that is purposely uh, over parameterized, so we can see the overfitting. So we compile the model using the Adam optimizer and set our loss function to spare categorical cross entropy, which is appropriate for classification tasks with integer labels. Now here notice after the convention layers, flatten the feature maps and add a dense layer of 256 neurons per unit. This is intended to over parameterized to illustrate how the model might overfit if not regularized. Now let's move on and let's train our dataset. We train the model for 30 epochs with a batch size of 64. Now I'm gonna pause the video here. Now during the training, we also evaluate the performance on validation set. This helps us to observe the overfitting, where the training loss decrease faster than the validation loss. You see, after some point, validation accuracy stopped increasing. Initially, it increased for a while and then it stopped increasing while training accuracy increased. This is a sign of overfitting. Now if we plot after the training, we will plot the loss curves for both training and validation loss, and we will see the sign of overfitting. As you can see, the validation loss is increasing rather than decreasing. So these plots helps us to visualize access the overfitting by comparing the progression and the progression of losses. Now to overcome this, in the next part we will address overfitting by building a regularized model. We reduce the complexity of the dense layer by reducing the number of units. Before, as we knew, we had a 256 units of containing 256 units layer. Now we decrease it with the 128. Now we add L2 regularize to penalize the large weight value and discouraging complex models. We also include a dropout dropout layer after the dense layer to help the further reduce of overfitting by randomly deactivating the neurons, 50% of neurons, and during the training. Now here the data augmentation is another key technique to improve the generalization. We use the image data generator to randomly rotate the image, shift them horizontally or vertically, and flip them horizontally. This creates a more diverse training set from our original images, helping the model to learn a robust feature. Now we are going to train our model again with the same settings. I'm gonna pause my video here. Now, after a long wait, the model has been trained. The fitting process is similar to the baseline model, except now we use the augmented data provided by our image data generator. Now let's again plot the graph between training and validation loss. And in a comparison, we can see the validation loss is also increasing, and now it's not overfitting. Now let's compare the both of the model. This is a side-by-side comparison, highlights the impact of regularization data and augmented data uh, on the model performance. In baseline model, the training accuracy was high, while the validation accuracy was okay. And in a regularized model, training accuracy is lower than the validation accuracy, but validation accuracy is higher than the training accuracy. Now finally, let's see some example of augmented images generated by our data generator. Some random images. So yep, in the summary today we have explored two models. The over-parameterized baseline model, which demonstrated overfitting due to its complexity and the lack of regularization, and the regularized model, which applied strategies like dropout layer, L2 regularization, and data augmentation to reduce the overfitting and improve generalization. By comparing their performance, it becomes clear how crucial these regularization methods are for the real world application. And thank you for watching the video. If you have any question, please leave a comment.